Hello, I'm going to provide a demo for test application. This is a task. So I'm building an application for a sports club. Currently there are several types of sport in a club, probably will be more in future sports. We need a system that allows to store members' first and surname, also the sport they play. For now it's not clear if member could play one or more sport. We need to figure this out and have a solution for that. Also, we need to build a single application. In future, members needed to have an access to their sports. This is a task in scope of this demo. I'm going to provide following. Here, during the demo, I've created a database. This is SQL database with entity framework, with a model first approach and based on migrations. So all data are created from migrations and from a code. Next, I will show a demo web API, which is built with ASP.NET Core 5. In the web API, I have authentication controller, sports controller, and participants controller. Also, I will make a demo of Postman collection with all public web API requests. Plus, I've created a React.js application with hooks and functional components. That's all for the demo scope. Now I will try to describe the data model we are working with. Here I will try to draw. So basically we have two types of data. First one is an identity data for users to be able to log in and have an access to our API. Plus we have separate set of data. It's our application data. So I've decided to split all the data to two major parts for now. First one is identity database. Second part is sports database. In the identity, it's a usual or simple ASP.NET Identity database, which lies under Identity Framework and has well-known tables like ASP.NET users with email, name, and all identity stuff like email confirmed and all the stuff basically from the identity framework. Identity. Yep. In the sports database, we have our data like basically types of sports. Also, we have participants. Participant is an entity which is similar to item we have in ASP.NET users, with a linking, with a weak link, if I can say, by the participant email. So each participant has an email, first name, and surname. Email is connected with our identity database, so this is connection between two databases. That's all for theory. Let me try to present databases. This is identity database and this is demo database. Identity consists of all ASP.NET needed tables with users, with roles, claims, logins, and all the stuff. Our demo database, our sports database, basically consists of two tables. First one is sports, type of sports, and second table is participants. So this is our model. In order to start an API, here is a README file with a description that in order to run this smoothly, it's better to create database, identity database plus application database, and provide connection strings in app settings file. In the web API, we have app settings with two connection strings. Next, in order to have a database schema and data to be seeded in the database, you need to run update database command from Entity Framework Core via Package Manager console and provide corresponding context. First one for identity, second one for application database. Here, some data or necessary data is seeded. Here we have something to put into our database just to not have it empty. Also, something is seeded into identity database. This is the user, which is possible to log in, and I will show a bit later our login procedures. So back to our web API stuff or web API project. Basically, it's a web API built with clean architecture in mind. I've built a domain first, then I've created persistence and all infrastructure around the domain, and finally I created a web API which uses the infrastructure to access and domain data. All the application logic is in a separate assembly here application. So let's check our domain. Basically we have two entities. First one is a sport entity. Has an ID, name, a list of participants. And participant entity, this is information about the person who is assigned or taking a part in some type of sport. Basically, this type of task is a pretty well known many-to-many relation solution or relation type task, where each participant could take part in several sports, and each sport could have several participants. I decided to not deal with many-to-many relationship in the domain model. That's why I've broken the this loop, this circle. For now, sport has a list of participants, but each participant has a single sport, but we have collection of participants. It's possible to see here at the database schema that sports has unique ID. Participant has a link to sport ID. So this is not many-to-many, but this is one-to-many. But with application logic, I provide all necessary API requests and responses. Next, about our project, we have persistence layer where we save data into normal database context. Database context has two properties, sports and participants. Also, it's responsible for seeding, and it's responsible for providing each entity has some kind of an audit. This is for making tracking of who has created or changed what and when. So this auditable entity is a base class for all my domain entities. And at the database context, I set all the necessary timestamps and user information who has done what. So this is database context, and this similar is identity context, which is inherited from identity framework DB context with application user, which has first name and last name additional entities. Next, application. The most complicated part of our solution is an application which is a piece of logic created for common query segregation responsibility pattern for working with the database, with the data. Here in the list of, in the features, so all application logic is divided by features. We have basically two features, participants feature and sports feature. We have special folders for all commands to manipulate or to mutate participants. And we have special set of queries in order to ask for participants. The same goes for all other entities like sport. We have commands and queries. At the command level, for example, let's check create participant command. This is just a command which has some data which are going to be used for creating an entity. Then it has its own validation, and it has a command handler, just piece of logic responsible for transforming parameters into domain entity via mapper, and then creating a domain entity inside the repository. Repository is for repositories, I have generic repositories here at the persistence level. Let me find here, we have base repository, which is generic and works with any entity we have. But in case if we need some more logic at the repository level, we have specific repositories with special methods implemented to work or to separate from DB context internals. So, for example, create command handler receives a request with parameters, does validation, checks for errors, and if everything, it transforms original input into domain entity, and then saves domain entity into the repository, into database via repository. Same is true for delete. It's a delete command executed in the handle with transforming parameters into domain object, and then request to the repository and then to the persistence level. If we check some query, for example, like this is a query for getting list of participants. It as well has parameters, has output type, which is not domain entity but data transformation object or view model. Here it's called view model. And the main handler, which transforms query with in this case the query doesn't have because this is get all, it doesn't have any parameter, but it transforms original call to the persistence level layer in order to get data and then transform domain objects into view model objects. Here at the get participant details, for example, this query has a parameter, it has an ID, so which participant or which person we are going to get details for. And then in the handler we do have a handle method to get data from the persistence from the repository, from persistence layer, transform into DTO, add additional logic, and then return list of data transformations objects to the caller, side. Basic logic is straightforward here. The same similar methods created for participants and for sports. Next, we have mapping profiles, some basic stuff like base response, okay, something for exception, and something for contracts. So async repository, participant repository, and sport repository is in the application logic, but corresponding implementation in the persistence layer with implementation of the DB context and execution of SQL commands via DB context against SQL database. At the web API level, we finally have three controllers. First one responsible for authentication and has two methods, to authenticate and to register user. Second controller responsible for CRUD operations for sports, like get all sports, get specific sport, update, create, and delete. The same set of commands created for participants controller, like get all, get single, create, update, and delete. So simple CRUD, but with mediator pattern implementation where, let's check, like participant, get participant by ID. So this is a mediator. It's implemented with a well-known mediator assembly or pattern implementation, where we have a query, and then we just send this query to the object who is responsible for reacting to this query. The same for commands. We are creating a commands and sending to mediator, and then the class responsible for reacting to this command is going to be executed and provide response. We could, like, let's check, this is an add sport because it has less amount of properties. So create new entity in the sports collection. For example, here add sport. We have a command which in the parameter has only a name. So this is for the sport table. Here, sports, select. So only name we are asking from a caller side. Then we are sending this command with all parameters to our mediator, and then it finds a responsible object to react to this command. Object to react to create sport command is in the feature sport create sport. Here it is. Here is a definition of the create command. This is definition of a handler. So handler is it reacts on create sports command and produces create sports command response. Implementation here is straightforward because inside the command we do inject our mapper and repository. In the method responsible to reacting to create command, we do following. We validate our input with a command validator, this one. Next, we check for errors in everything. If everything is fine, we create a domain object, use binding for, basically the same could be achieved with a mapper, but here I decided to be very specific. And then we send domain object to the persistence layer, to the sports repository implemented with the entity framework database access pattern. And then we do provide a response, which is command response, create command response, which has created object as a result. probably that's it for the application structure and description what's going on here at the application level. It's already started right now. At the database, we have two tables with some dummy data, and also we have one user. It's persisted during the seeding of the identity database. Here it's possible to execute a bunch of requests from a postman. I will just go briefly about the usage of our API. So here we have authenticate method, which is taking email and password and provides a token. Then we have method to register new user. It could be any user as soon as the data is valid. Next, we have a set of API calls to work with sports, like get all sports. And as a result, it has squash and tennis. Also, get single sport by ID. Let me just grab, for example, ID for squash and execute this one. Yep, here a single entity. Also, command for creating new sport like football. Oops. Current solution does not have any error handling or well-defined error handling. This exception here actually says that we don't have an access token. So I'm going to log in, grab the token, use the token in my create command and execute. Boom, we have new item, football in list of our sports. Here we have only two of them. Oops. Now we have football. So this is create command. Same works for update with authentication token by ID and with a name of new field or name with a new name. Same goes for delete with a token. And set of commands to work with our participants. This is a list of all participants, specific participant, create, update, and delete for participants entity. From the original task description, I found out that we need to figure out if some member, or some club member is assigned to more or one or more sport. For this very specific business logic queries, I've created two additional requests. First one, at the sports level. Here, sports level, we have a request for getting all sport entities with its items, with its sub-items. So here at the sport level, get all sports with participants. If we execute this one, we have football, we have squash with only one participant, and we have tennis with two participants. So from this response is basically possible to figure out if the person is assigned to one or more sports, but it's from a sports point of view. So this is sports with all the participants or child elements for the sport. In order to take a look at the same data but from a different point of view, I've created a method at the participants level in order to get all sports for specific participant. Here at the participant level, the ID or the key for new participant is an email. So at this case, John Doe has two sports, this one and this one. special API calls for that is to get all sports for provided email. If I execute this one for John Doe, we can see that he has squash and tennis. So the main answer in the task assignment to find out one or more assigned to a sport is basically this single API call, which gives us an answer how many type of sport this person is taking part or assigned to. Probably that's it for an API call and API stuff. Now we can take a look at the front-end part, which is our Angular application. Oh, damn it, sorry. Yeah. React.js application built with hooks. I'm, as you probably know, Angular. Yep. As you probably know, I used to work with Angular some time ago, but this assignment requires React.js, which is awesome from my point of view. I'm new to React, and I just read about React a bit and try to build something based on some, I believe, nice ideas like context API, like hooks, and the latest way to build React applications. Just to make complete project simple, I've repeated several API requests here from my client application in a way of REST API client. So here we can authenticate, obtain a token, we can create a patient, we can get list of all sports right here, list of all sports with participants, specific sport, create read update operations with a token. Token need to be updated to the latest one obtained from Auth API. The same for participants. Get list, get all, get by participant email, and get specific one. So just to make all API requests in front of my eyes. Here is an application. We're of course starting from an index which hosts our app. Our app is list of two components. Login, or maybe it's better if I start with a demo actually. Demo itself doesn't consume all API, it just consumes a list of sports and provide an ability to create, modify, and delete a sport entity. So let me start the test application. Here I've hard-coded the credentials to make it simple to log in. From here we have an API response from all our sports. We can create, I don't know, I've already used football. Let's swimming, hard sport. We have new item. We can modify this here and save, or we can delete. Together with this demo, you can see how my design skills are amazing. So this is a client application to be able to log in, log out, and do CRUD operations for sports. If we take a look at how this application is built, it's application with two components. First one is login form, and second component is a holder of protected pages. Here at the app level, we decide if the user is authenticated or not and use authentication context for that. Our authentication context model consists of property is logged in, of current token, and several methods. Implementation, once again, right here. For example, let's take a look how our authentication is done. So here is a login form. Where is our component login? This is our login form. It has username and password. Oh, sorry, email and password. It has login handler, which then execute our account service API method in order to login user and then pass information to the authentication context login function. Let me go right here. Where is it? Here, adds login stuff. We have two methods, authenticate and register. The same, we have several methods to work with our sports API. Next, add the sport application. We have our main app for sport entity, which then holds a header, sport form to create new item, and table to display list of items from the model. Sport form is built with what do we have here? Just a name. Yep, this is just a name and submit handler. At the submit handler, we do save data to the API. Header is just a text. What else do we have? This is table, an editable table, which holds view row or edit row. View row displays with edit and delete, and edit allows to save or cancel. All the logic built based on hooks. Let's take a look, for example, edit sport row. So here are stuff for manipulating state of the component via hooks. The funny stuff here is this form hooks. It's a thing for having all common logic for all UI forms into single place, just because this is just repeated code. Probably that's it for the demo. I believe I already started it here. Allows me to create something, remove. Awesome. Yep. All source code is published to a GitHub with original task, with API, and with UI application. Probably that's it. Thank you very much. It was really interesting to try myself at the well-known API and absolutely not known React applications. Thank you very much. See you.